A train traveling at 600 miles per hour through a vacuum tube under the ocean. A floating highway that moves itself. A tunnel boring machine the size of a building carving through solid rock faster than you can walk. These aren't concepts from a sci-fi movie. They're being built right now, and some of them will be operational before your next car needs new tires. So buckle up, because the future of getting from point A to point B is about to get weird. Let's start with the project that sounds the most insane and somehow might be the closest to reality. The Fehmarn Belt Tunnel connecting Denmark and Germany. This isn't just another tunnel. It's an 11-mile underwater highway and railway sitting in a trench 130 feet below the Baltic Sea. The entire thing is being built on land, in massive concrete sections, each one weighing 73,000 tons. That's heavier than the Eiffel Tower. They're building these sections in a factory, floating them out to sea, sinking them into a pre-dug trench, and connecting them like the world's most expensive Lego set. Why go through all this trouble? Because right now, if you want to get from Copenhagen to Hamburg by car, you're taking a ferry. That's a 45-minute boat ride, assuming the weather cooperates and the ferry isn't full. With the Fehmarn Belt Tunnel, that same trip takes 7 minutes by train, 10 minutes by car. The tunnel will move 10,000 cars and 78 trains per day when it opens in 2029. That's not 2030. That's next decade. This thing is happening. The engineering is bonkers. Each tunnel section is 217 yards long. They dig a trench in the seafloor using specialized dredging ships, lower these massive concrete tubes into position, and then cover them with rock and gravel. The precision required is insane. They're positioning 73,000-ton objects underwater with an accuracy of a few centimeters. One section off by even a meter and nothing connects properly. And here's the part nobody talks about. The Baltic Sea isn't calm. It freezes in winter. There are unexploded World War II munitions on the seafloor that had to be cleared. They found over 50 bombs during the initial surveys. Torpedoes. All kinds of fun stuff. Clearing those before construction could start was its own mega project. Moving on to something that makes the Denmark Tunnel look simple. The Mumbai Trans-Harbour Link in India. This is a 13.5-mile bridge and tunnel system crossing Thane Creek, connecting Mumbai to Navi Mumbai. Sounds straightforward until you realize it's being built in one of the busiest shipping lanes in Asia, in an area with some of the most challenging geological conditions on the planet. The bridge portion alone required driving foundation piles 200 feet into the seabed through soft marine clay. That's like trying to build a house on pudding. The clay shifts. Each one is 50 feet in diameter and goes down until it hits rock. But the really wild part is the tunnel section. They're using tunnel boring machines, TBMs, to drill through rock underneath an active shipping channel. These machines are 40 feet in diameter and over 400 feet long. They chew through rock, lay concrete segments behind them as they go. The Mumbai project is supposed to cut travel time between the two cities from over an hour to about 15 minutes. For a metropolitan area with over 20 million people, that's transformative. We're talking about reuniting a city that's been split by geography for decades. When this opens in 2027, ahead of our 2030 timeline, it'll be one of the longest sea bridges in the world. Now let's head to Southeast Asia for something even more ambitious. The Kuala Lumpur-Singapore high-speed rail. Or at least it was ambitious until Malaysia kept canceling and restarting it. But as of 2024, it's back on, and this time it might actually happen. Maybe. Hopefully. We'll see. This is a 220-mile high-speed rail line, connecting two of Southeast Asia's major cities. Trains traveling at 200 miles per hour, cutting the journey time from over 5 hours by car to 90 minutes by rail. The technology isn't new. Japan's been doing this since the 1960s with the Shinkansen. But building high-speed rail through tropical jungle with challenging terrain and crossing international borders? That's new. The route passes through some of the last remaining rainforest in Malaysia. Environmental concerns have plagued this project from day one. How do you build a railway through pristine jungle without destroying everything? The answer is elevated sections and tunnels. Lots of tunnels. The trains will spend miles underground to avoid surface disruption. There's also the political aspect. Two countries have to agree on everything. The technology, the contractors, the financing, the operational procedures. Malaysia and Singapore don't always see eye to eye. The project has been cancelled twice already because they couldn't agree on terms. The current restart has a revised agreement that supposedly solves these issues. We'll believe it when we see trains actually running. But if it happens, and that's still an if, it completely changes regional transportation. Suddenly, you can live in Kuala Lumpur and work in Singapore, or vice versa. The economic integration potential is massive. It would create what urban planners call a mega region, where two major cities function as one economic unit. Let's pivot to something that's definitely happening, because it's already under construction, and too far along to cancel. The Brenner base tunnel connecting Austria and Italy through the Alps. This is going to be the world's longest underground railway tunnel when it opens. 40 miles straight through solid mountain. The interesting thing about this project is they're drilling from both ends and meeting in the middle. Except they're also drilling from several points along the route through access tunnels. So you've got tunnel boring machines working from maybe half a dozen locations, all of them having to meet up with millimeter precision. The surveying alone is a nightmare. You're inside a mountain, you can't use GPS, and you have to calculate exactly where you are based on incredibly precise measurements, and a whole lot of math. They've been digging since 2007 and they'll be finished by 2032. Yeah, slightly past our 2030 cutoff. But close enough. Freight trains will be able to cross the Alps in 20 minutes instead of the current 2+ hours. That might not sound exciting until you realize the Alps are one of the major bottlenecks in European freight transportation. Trucks spend hours crawling through mountain passes, burning fuel, causing accidents, creating pollution. This tunnel eliminates that. Freight trains carrying containers from Italy to Germany will blast through at 100 miles per hour underground, barely slowing down. The environmental impact alone is worth a €10 billion price tag. They estimate it'll remove 400,000 truck trips per year from alpine roads. That's fewer accidents, less pollution, and cheaper shipping costs for goods moving through Europe. Now for something completely different. The Hyperloop test track in Saudi Arabia. Yeah, Hyperloop. The thing everyone said was impossible and would never work. Well, Saudi Arabia is building it anyway because they have unlimited money, and apparently a fondness for ambitious transportation projects that make everyone else nervous. For those who don't know, Hyperloop is this concept where passenger pods travel through low-pressure tubes at incredibly high speeds. We're talking 600 to 700 miles per hour. And theoretically, you can move people faster than airplanes while using a fraction of the energy. The Saudi test track is a 22-mile proof of concept connecting two cities. If it works, they're planning to expand it to connect Riyadh, Jeddah, and other major cities. The claimed travel time from Riyadh to Jeddah, normally a 9-hour drive, would be 76 minutes. That's faster than flying when you account for getting to the airport, security, boarding, and all that nonsense. The skeptics, and there are many, point out that Hyperloop has never been proven at scale. The test tracks that exist are tiny. Building 22 miles of vacuum tube through desert is going to reveal all kinds of problems nobody has anticipated. What happens when sand gets in the tube? How do you maintain vacuum pressure over that distance? What happens if there's a leak? What happens if a pod breaks down in the middle of the tube? Valid questions. All of them. But here's the thing. The Saudis don't care about skeptics. They're building it anyway. Construction started in 2023, and they're targeting 2026 for initial operations. Whether it works or becomes a very expensive monument to hubris remains to be seen, but you can't accuse them of thinking small. Let's talk about something that's less theoretical and more this is definitely happening because they're already halfway done. The Hong Kong-Zhuhai-Macau Bridge. Oh wait, that opened in 2018. Scratch that. But it's worth mentioning because it set the template for what we're about to discuss. The Shenzhen-Zhongshan Bridge currently under construction in the same region. This is another massive bridge tunnel system crossing the Pearl River Delta in southern China. 15 miles long, combining bridges, artificial islands, and an underwater tunnel. The bridge sections are cable-stayed designs with towers reaching nearly 900 feet high. The underwater tunnel section is a 4-mile tube sitting 130 feet below the surface, built using the same immersed tube technique as the Denmark Tunnel. What makes this interesting is the speed of construction. The Chinese started this in 2016, and they're finishing in 2024. That's 8 years to build 15 miles of bridge and tunnel across open water. For comparison, the San Francisco-Oakland Bay Bridge retrofit took 24 years. The Chinese are doing transportation infrastructure at a pace that makes everyone else look like they're moving in slow motion. The bridge will cut travel time between Shenzhen and Zhongshan from 2 hours to about 20 minutes. For context, this region, the Pearl River Delta, has a population of 86 million people. That's more than the entire United Kingdom. Connecting these cities efficiently isn't just about convenience. It's about economic integration on a scale most countries can't even imagine. Now let's head to Africa for something that deserves way more attention than it gets. The standard gauge railway being built across East Africa. This is a Chinese-financed and built railway system connecting Kenya, Uganda, Rwanda, and eventually the Democratic Republic of Congo and South Sudan. The first phase from Mombasa to Nairobi in Kenya is already operational. The ultimate goal is a network spanning thousands of miles. This matters because Africa has a transportation infrastructure problem. Railways are either non-existent or left over from colonial times, running on outdated gauges with ancient equipment. Moving goods across the continent is slow, expensive, and unreliable. This railway system changes that. The trains travel at 75 miles per hour, carrying both freight and passengers. The journey from Mombasa to Nairobi used to take 12 to 36 hours depending on road conditions. By train, it's 4.5 hours. For freight companies, that reliability is worth more than speed. They can actually predict when goods will arrive. The political complexity here is intense. And East African politics are complicated, to put it mildly. There are concerns about Chinese influence, about debt, about sovereignty. Kenya borrowed billions from China to build this, and there are questions about whether they can pay it back. But regardless of the politics, the infrastructure is being built, and it's changing how goods and people move across the region. Back to Europe for our next project. And this one is delightfully weird. The Fehmarn Belt Fixed Link. Wait, we already talked about that. No, different project. This is the HS2 high-speed rail in the UK. Oh boy, here we go. HS2 was supposed to be Britain's answer to high-speed rail. A 330-mile system connecting London to Birmingham, Manchester, and Leeds. Trains traveling at 225 miles per hour. It was going to revolutionize British transportation. Then the cost ballooned. The timeline slipped. And as of 2024, they've scaled it back to just the London to Birmingham section. Maybe. But here's why it's still on this list. Despite all the problems, they're actually building it. There are massive tunnel boring machines carving through the Chiltern Hills. There are construction sites across southern England. Billions have been spent. It's too late to stop now, even if they wanted to. The London to Birmingham section is supposed to open around 2033. Yeah, that's past 2030. But the groundwork happening now will define British transportation for decades. If it works, if it comes in anywhere close to budget, if public opinion shifts positive, the extensions to Manchester and Leeds might happen. If it becomes a cautionary tale, it'll be the last major rail project Britain attempts for a generation. The technical challenges are significant. Britain is densely populated. Building new rail lines means either tunneling under things or dealing with land acquisition and environmental concerns. Viaducts, bridges, stations, all while existing rail service continues. It's complex, it's expensive, and it's politically toxic, but it's happening, and we're going big. The North-South Expressway Corridor in India. This is part of the Bharatmala Pariyojana program, which is the most Indian name ever for a highway project. The goal is to build 50,000 miles of new highways across India by 2030. Yes, 50,000 miles. That's enough road to circle the Earth twice. The flagship component is the North-South Corridor, a 800-mile expressway from Srinagar in the north to Kanyakumari in the south. This will be India's first true high-speed expressway system, with access-controlled highways, consistent lane widths, and modern safety features. National roads, state roads, and paths that are optimistically called roads but are really just suggestions of where a road might someday exist. The construction is happening in phases. Some sections are already complete and operational. Others are under construction. The timeline says everything will be done by 2030, but anyone familiar with large infrastructure projects in India knows that's optimistic. Still, even if it takes until 2035, the impact will be transformative. India's economy is growing fast, But transportation infrastructure is a major bottleneck. Goods take forever to move between cities. Trucks break down on terrible roads. Transit times are unpredictable. This expressway system fixes that. Suddenly, you can drive from Delhi to Mumbai in 12 hours instead of 24. Freight companies can plan routes and schedules with confidence. The scale is what makes this remarkable. They're not building one highway. They're building an entire network. Different contractors, different states, different geological conditions. All of it has to integrate into one coherent system. The project management alone is a mega project within the mega project. So there you have it. 8 mega projects that will change how we move people and goods around the planet. Some of them are definitely happening. Some of them are probably happening. And one of them, looking at you Hyperloop, might end up as a very expensive learning experience about why vacuum tubes and reality don't always get along. But here's what ties all of these together. Every single one of these projects is happening because someone looked at how we currently move around and said this isn't good enough. They saw bottlenecks, inefficiencies, opportunities. And instead of accepting the status quo, they decided to drill through mountains, sink tubes under oceans, and build bridges across some of the most challenging environments on Earth. The technology isn't science fiction. It's engineering, really impressive engineering. Tunnel boring machines, immersed tube construction, high-speed rail, cable-stayed bridges. All of this exists and works. We're just applying it at scales and in combinations that weren't possible or economical before. And yeah, some of these projects will fail. Some will go over budget. Some will take longer than promised. That's infrastructure. But the ones that succeed will define transportation for the next century. They'll change where people can live, where businesses can operate, how goods move across regions and continents. The future of transportation isn't flying cars or teleportation. It's better versions of the stuff we already have, built bigger, faster, and smarter. It's less exciting in concept, but way more exciting in practice when you realize what it enables. Thanks for watching. More mega project deep dives coming soon. Hit subscribe if you want to see them.